Question 31. If the distance between two suspended masses 50 kilograms each is quadrupled, the gravitational force of attraction between them is. Now we know that this is the formula for the gravitational force of attraction, which is the product of the masses of the bodies all over the square of the distance between the bodies. But we can rewrite this formula as simply the gravitational force being indirectly proportional, to the distance between the bodies. And the question now tells us that the distance between the bodies is 4 times the distance is quadrupled, right? So place this into this formula, then we now get that this now becomes 4 arrows squared, now becomes 16 arrows squared, right? And so this was arrow squared, it is now 16 arrow squared, meaning that the gravitational force of attraction is now indirectly proportional to 16 times the distance between the bodies after the distance was quadrupled, meaning that the answer is D. The gravitational force is reduced by 16. Question 32. In a simple machine, the variation of efficiency with load is a parabola. The variation of efficiency with load is a parabola in a simple machine. That's option A. Question 33. Binding energy is. Now we have 4 options here. The first one says the amount of energy released when protons change energy levels. The second option says the amount of energy released when electrons change energy level. Third option says the amount of energy required to break a nucleus apart into protons and neutrons. And then the last one says the amount of energy released, or the amount of energy required to break a nucleus apart into protons and electrons. And we can look at option D, for example. The nucleus does not contain protons and electrons. It contains protons and neutrons. So automatically option D is out. Now for option A and B, binding energy is not the amount of energy that is released when protons or electrons change energy level. So that means that our answer is C, which is the amount of energy required to break a nucleus apart into protons and neutrons. So that is option C. Question 34. If the heat capacity of 100 grams of a substance is 3000 joules per Kelvin, what would be the heat capacity of 10 grams of the substance? So once again, we're given these parameters. We're given the mass to be 100 grams, which is we convert to kilograms, and we have the heat capacity to be 3000 joules per Kelvin. And we know that the formula for heat capacity is mass times specific heat capacity. So this small c is specific heat, this big C is heat capacity, which is the one we're given, and we have our mass. So we find the specific heat capacity, which is simply the heat capacity all over the mass, and that becomes 30,000 joules per kilogram per Kelvin. But we're looking for the heat capacity of 10 grams of this substance. So now that we have the specific heat capacity, we know that 10 grams will be 0.01 kilogram. So plug it back into our formula. We have the new mass, which is this, and then we have our specific heat capacity. So when these are multiplied, we get the heat capacity to be 300 joules per Kelvin for 10 grams of the substance, which is option B. Question 35. Wooden ladles are commonly used domestically to scoop hot soup because of it. Now, you can already read the question there. The question is talking about scooping hot soup. That means that we're dealing with heat. So automatically that removes option A, B, and C because you can see electricity there. Electricity has nothing to do with hot soup, So that removes A, B, and C. And that brings us to the answer, which is D, good insulation of heat, right? So when you're scooping hot soup, it's going to be very hot, obviously. And so you need a spoon or a ladle that will be able to help you scoop it without feeling the full brunt of the heat and burning yourself. So the answer will be option D, good insulation of heat. Question 36. Which of these thermometers uses the volume of a fixed mass of liquid as its thermometric property? Now we have 4 options: mercury in glass, thermocouple, constant volume of gas, and resistance. Now let's start from resistance, for example. You can already see that it's called a resistance thermometer, meaning that it uses the resistance to measure the temperature. So that automatically removes it as an answer because we're looking for the volume of a fixed mass of liquid. Option C says constant volume of gas, which removes it. And then B says thermocouple thermometer. Now we know that the thermocouple thermometer uses the potential difference or the voltage difference, to be able to find the temperature. So that removes it. That means that our answer is mercury in glass. Mercury is the liquid that's used, in the mercury in glass thermometer. So that's option A. Question 37 says, as pressure is increased, what happens? I will have four options here. The first one says the melting point of the ice decreases, the melting point of the ice increases, the boiling point of water decreases, and no change is observed in the melting point of ice. From the get-go, we know that option D is out, because there's a change that's actually observed. Now look at option C. It says the boiling point of water decreases. But we know that as pressure is increased, boiling point of water actually increases. So that's out. Now that leaves us with option A and B, which are both talking about melting points. But option A says decreases and option B says increases. Now, the answer is actually option A, which says the melting point of ice decreases. And this is because when pressure is increased, right, it reduces the volume, and the volume of water is now less than ice, so it will be easier for it to change states. So that means that it's going to take a lower temperature than before, to be able to melt the ice. So the melting point of ice actually decreases. So that is option A. Question 38. Which of the following statements about the gamma ray is or are true? We have four statements here. One says it carries a negative charge. Two says it can be deflected by both magnetic and electric field. Three says it can be stopped by a sheet of paper. And then four says it has zero rest mass and a neutral charge. Now, let's start from the first one. I says it carries a negative charge. But we know that gamma ray does not actually carry a negative charge. The ray or the type of, particle that carries a negative charge are beta particles. So that removes one. Now the second one says it can be deflected by both magnetic and electric field, and that is also wrong because it's alpha and beta particles that are deflected. Now the third one says it can be stopped by a sheet of paper. A sheet of paper actually stops only alpha rays. It takes a lead block to be able to stop gamma rays, so that removes it. So that automatically means that option 4 or statement 4, which is it has zero rest mass and a neutral charge. That is actually true about gamma ray because gamma ray does not have any charge and it actually has zero rest mass, So that is option D in this case, which is 4 only. Now question 39 says a cyclist of mass 30 kilogram exerts a force of 250 newtons to move his bicycle. The acceleration produced is 4 meters per second squared, and we're meant to find the frictional force between the road and the tires. Now, once again, we get all our parameters, and we have the mass, which was given to be 30, acceleration to be 4 meters per second squared, and the force, which is 215 newtons. Now, we're representing frictional force as Fr, which is simply the force minus mass times acceleration. Now, I know that this is also force, but this force is the force that was exerted, and this force is the other force that is caused by the mass and the acceleration. So to get the frictional force, that will simply be 250 minus 30 times 4, which will be 250 minus 120, which is 130 newtons. And that is option B. And then question 40 says that the temperature of land rises more quickly than that of the sea because the specific heat of the soil is. The answer is B. The specific heat of the soil is less than that of water. So that's why the temperature of the land rises more quickly. Specific heat talks about the quantity of heat that a body, or a substance can hold, until it now changes its temperature. So you say that, for example, on a hot sunny day in the beach, you touch the soil or you touch the sand on the beach and it is quite hot, but then you go to the water and then, it might be mildly warm, I am wondering, but it's the same sun that is shining over the surfaces. So this is the reason. The temperature of the land is rising more quickly because the sea has a higher specific heat, than the land, or than sand in this case. So in this case, the specific heat of the soil is less than that of water, which is option B.